In this video, we're going to look at an introduction to matrix multiplication. Matrix multiplication has numerous applications in many areas of mathematics, as well as in applied mathematics, statistics, physics, economics, and engineering. If you're looking at a slightly more advanced multiplication, please refer to my matrix multiplication video or my video on using the graphics calculator for matrix operations. The number of columns in the first matrix must equal the number of rows in the second matrix. In other words, the inner dimensions must equal the outer dimensions of the matrices. The product of two matrices is another matrix. The order of the product of the matrices is the number of rows in the first matrix multiplied by the number of columns in the second matrix. In other words, the outside dimensions. For example, if we multiply matrix A by matrix B, we get matrix C. In order to multiply them, the number of columns in matrix A, highlighted in green, which is 3, must be the same as the number of rows in matrix B, highlighted in green. The result of the multiplication of matrix A and matrix B is a matrix of dimensions 1 by 2. That's obtained by the number of rows, which is 1 in matrix A, and the number of columns, which is 2 in matrix B. The product of two matrices is found by multiplying the corresponding elements in each row of the first matrix by the column of the second matrix and then adding them together. Let's start by looking at an example. Suppose you had some friends and you go to the local fish and chip shop. You decide you want 3 bags of chips between you at a cost of $4 each. In addition, 2 friends want a dim sim. You can get 2 dim sims for $2. You can calculate the total cost by multiplying the number of each item by its respective cost and then adding the results together as follows. So we've got 3 bags of chips at $4 plus 1 bag of dim sims for $2, and we get a total cost of $14. An alternative would be to construct a row and a column matrix to represent the quantity and cost and multiply them together. Here we have a row matrix for the quantity multiplied by the column matrix for the cost. Remember, the number of columns in the first matrix must equal the number of rows in the second matrix, which is 2, and it does. That's highlighted in green. The product of the two matrices is found by multiplying the corresponding elements in each row of the first matrix by each column in the second matrix, and then adding them together. Here we only have 1 row and 1 column, therefore we multiply the corresponding elements and then add them together, and we get 14. Which is a 1 by 1 matrix, which is the number of rows of the first matrix and the number of columns of the second matrix. Here we get the same answer as above, which is $14. In the previous example, we constructed a row matrix and a column matrix to represent the quantity and cost of each item respectively. Then we multiplied them together to find the total cost. We could have written down those matrices with variables or prenumerals like this. If we'd written the column matrix first and the row matrix second, we would have produced a very different result. Remember, the product of two matrices is another matrix. The order of the product of the matrices is the number of rows in the first matrix multiplied by the number of columns in the second matrix. The product of the two matrices is found by multiplying the corresponding elements in each row of the first matrix by each column of the second matrix and then adding them together. The purpose of this is to show that the order matters when multiplying matrices. We'll explore this further in my multiplying matrices video. This is only an introduction, so we're not going to go any further into it. So this was quite a simple order in the last example. Continuing on from that, if we wanted to add additional items to our order, we might represent the total cost using matrices. We could have added another item to our order and multiplied them together, or another item. There's really no limit to the amount of items we could have added to the order. Thank you.